Okay, pi over 6 radians is how many degrees, just so we have an idea of what we're talking about. That's 30 degrees. I know you guys are very, very comfortable in walking around a circle in 30-degree chunks. We're going to do it with pi over 6 chunks. Down here we start with 0. 30 degrees would be right here. That's 1 pi over 6. What would you call this one? 2 pi over 6. Now, don't you start reducing on me right now. We'll worry about that later. What would the one at the top be called? 3 pi over 6. Go another 30 degrees, another pi over 6 units. 4 pi over 6. 5 pi over 6. 6 pi over 6. Now we'll go to the bottom half of the circle. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. What should we be ending with? 12 pi over 6. Of the 16 major points on the unit circle, didn't I just get most of them? By counting in increments of pi over 6, you just hit 12 of the 16 points. We only missed 4 of them, which we'll talk about in a minute. All I did was 1, 2, 3, 4, 5, all the way around. Yes, I know that some of them reduce. And yeah, we'll do that now, okay? But you can get every single, almost, you can get a lot of the radian measures around the circle just by counting by increments of pi over 6. So, what reduces on the top half? We got pi over 3. Yeah. What about the one at the top? Pi over 2. Yeah, nobody at a party is going to call that one 3 pi over 6. But they will call it pi over 2. Okay? Yes. Yeah, I know. But they will. 4 pi over 6. That's 2 pi over 3, right? How about 6 pi over 6? Call that pi, right? Any questions about those that reduced? Okay, now let's go down to the bottom half. We got 4/3 pi, or 4 pi over 3. You can call it either one. What about the one at the bottom? 3 pi over 2. Okay, what about 10 pi over 6? That reduces, right? 5 pi over 3. And how about 12 pi over 6? 2 pi. We just hit the majority of the major points on the circle, and all we did was count around in increments of pi over 6 radians. Now, for the ones that we didn't get, you know what? Yeah, we'll do it. We'll do it here. That's fine. We'll just do it in a different color. If this is 0 down, oops, better lock that in place. If we've got 0 right here, then this one right here is the 45-degree mark. Now, what is 45 degrees in radians? If we multiply by pi of radians over 180 degrees, what do we end up with? How many times does 45 go into 180? 4 times. So pi over 4 radians. Where would 2 pi over 4 be? At the top, right? What would you call the next blue mark? 3 pi over 4. And then, of course, there's 4 pi over 4. What's the one after that? 5 pi over 4. You guys are getting the hang of this counting thing. And at the bottom, 6 pi over 4. And the missing one in the middle of quadrant 4, 7 pi over 4. And lastly, 8 pi over 4. So the 4 that you were missing were these 4. All we did was count around the circle in increments of pi over 4. So if you can count around the circle in increments of pi over 6, if you can count around the circle in increments of pi over 4, you can name all of those same degree measure angles in radians. Any questions about that so far? Okay. Pause because I think I need to bring up a different page for you. Yep, I need to bring up a different page. Okay. Cover up your notes that you just wrote down about the unit circle. I want to see if you can answer some questions for me. I don't want anybody cheating and looking at their circle. Okay? Not looking at it, right? Okay, now you get to talk to James. I need you to think about this. I'm going to give you a radian measure, and you tell me what letter it is. Okay? Alright? Okay? Okay, so don't be looking at it. Okay, so we're going to start off with 7 pi over 6. 7 pi over 6. I need you to look, and I need you to find which letter represents 7 pi over 6. Be quiet and discuss it with your neighbors. 7 pi over 6. Yes. You gave me 6 pi over 6. I want 7 pi over 6. What letter? You are correct. Letter J is your 7 pi over 6. Okay? Count it out. 1, 2, 3, 4, 5, 6, 7 pi over 6. Okay? Three pi over 2. 3 pi over 2. 3 pi over 2. Count around the circle in increments of pi over 2 if you need to. 3 pi over 2. 3 pi over 2. 3 pi. Yes. It's true. Yeah. Now, let's think about this. 1 pi over 2 is how much? Like, you know that you are correct. So pi is all the way over here, right? So pi over 2 would be here. So if that's 1 pi over 2, 2 pi over 2, 3 pi over 2. You should know this, right? McDonald and Marshall should definitely get it. Okay. You should have chosen letter M. Letter M. Okay. 1 pi over 2, 2 pi over 2, 3 pi over 2. Where would 4 pi over 2 be? Which letter? Hey! I'm going to use that joke in 7th grade so much. I am definitely going to remember that one. Okay. 3 pi over 4. 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 3 pi I'm really glad. One pi over 4, 2 pi over 4, 3 pi over 4. Letter G. 3 pi over 4. Remind me how many degrees are in pi over 3 radians. Pi over 3 radians. Pi over 3 radians. 30. That would be pi over 6. How about pi over 3? That's 60 degrees, right? Keep that in mind. Negative. You heard that? Negative 2 pi over 3. Now, some of you in this room don't like pi over 3 increments. And some of you will actually convert it to pi over 6. So, negative 2 pi over 3 is how many pi over 6s? Negative 4 pi over 6. I actually know a lot of students that say, I think in terms of pi over 6 is better, so I'll do negative 4 pi over 6. It's exactly the same place. So whether you say negative 2 pi over 3 or negative 4 pi over 6, find that letter. It is going in the negative direction, not the positive direction. Negative 2 pi over 3. Correct. We got this down. No. What they say? Wow, look, it's back here. Oh. Okay, no, good answer. Shot. Yeah. Okay. Each one of these big chunks right here is a 30-degree chunk. Each one of the little ones. Several of you told me letter L, and you would be correct. Okay, watch. Negative 1 pi over 3. Negative 2 pi over 3. Now, if you like the pi over 6s, I'll count that way too. Negative 1, negative 2, negative 3, negative 4 pi over 6s. We're still at the same spot. So for your 60-degree chunks, there's a 60-degree chunk, and you need 60 more. If you're thinking in degrees. I gotta get you to think radians. Thirteen pi over 6. 13 pi over 6. Yes, folks, that's past the whole revolution. You can do it. 13 pi over 6. Yes! Oh, yeah, that's easy. Yeah. Yes! I'm so proud of myself. I just want to have you. Yes. Oh, it's beautiful. I just wanted to say, you should definitely hear your. Okay, lots of you chose letter B. You are correct. Yeah. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? It really doesn't matter how many times we go around. We're just counting in increments of pi over 6. Now, if you want to be smart about this, you could say, well, 13 is past 12 pi over 6, so I'll take 12 away, and that leaves me with 1. You can do it that way too, right? You can get rid of the whole revolution and just deal in what's left over. What? You will definitely get a blank circle that will look very similar to this on the test. Okay? So when we get there, I'll have this. I mean, if you notice, it's got a little bit of scale on it, but that's it. It's got the. It's really nice if you have a good circle to start with, because if you have to draw your own circles, you might make mistakes. And so when it comes to test time, we definitely need you to have good circles. Okay? You could practice drawing circles, you know. If you have a large enough room, you know, and then you do that chalk thing they like to do, you know. Try to draw your own, you know, circles. Okay. Yes, you need to know all the radian measures on the circle, but it is as easy as counting. There are lots of your friends who are not thinking about it in terms of counting in other classes, and so if you're talking with them and they're like, oh, I got to memorize the unit circle, show them that counting idea. It will help them out a lot. Okay, now, I want to write down a few numbers and ask you a question. Do you agree that these 4 numbers are in increasing order from left to right? Okay? If I took the square root of each one of these and divided them all by 2, some of them reduce and some of them do not. What does the square root of 1 over 2 reduce to? That's just 1/2, right? Radical 2 over 2 doesn't reduce. Radical 3 over 2 doesn't reduce. Radical 4 over 2 does. What is it? 1. Those numbers are still in increasing order from left to right. I need you to focus on quadrant 1 only at the moment. Quadrant 1 only. Can you tell me what x value I'm marking right now? 0. Can you tell me what x value I'm marking right now on the far right side of the circle? 1. Okay. And what's in the middle? 1/2. 1/2. These other 2 marks that I'm putting on here are radical 2 over 2 and radical 3 over 2. Do you see that they are in order? What y value do you think I'm marking right now in purple? What y value at the top of the circle do you think I'm marking right now? 1. What's in the middle? 1/2. These other 2 marks that I'm putting down here are radical 2 over 2 and radical 3 over 2. Do you see that they go in increasing order? On the far left, the x value is -1. What's halfway in the middle between 0 and -1? -1/2. What do you think this mark is that I'm putting between -1/2 and -1? Closer to -1/2 than it is to -1. Negative radical 2 over 2. And what do you think the last one has to be? Negative radical 3 over 2. Once again, folks, they go in order. Down here at the bottom of the circle, -1 is the y value I'm indicating. And what's halfway between 0 and -1? -1/2. And what y value do you think I'm marking with the purple one that's closer to -1/2 than it is to -1? Negative radical 2 over 2. And how about the mark that's closer to negative 1 than it is to negative 1/2? Negative radical 3 over 2. It is extremely important that you know those numbers around this circle and how they are in order. Because I can start asking you questions like, what's the cosine of 2 pi over 3? Now, you don't get a calculator for this. Even if I gave you the 4-function calculator, it really wouldn't help you at all anyway, so might as well give it to you. Is cosine an x value, a y value, or a slope? First of all, I need to know it's an x. Good job. Do you know where 2 pi over 3 is? 1 pi over 3, 2 pi over 3. Now, if you don't like the pi over 3s and you want to go with the pi over 6s, sure. That would be 4 of them, right? 1, 2, 3, 4. You're still going to land at the same place. Can you tell me what the x value is at that location? It's like negative 1/2. Now, I have been helping people in the resource room from other teachers. They do not talk about the scale. Not a lot of them. They talk about triangles. Yes, we can do everything with triangles. We can look at this as a 30, 60, 90 right triangle. Yes, we can do that. Okay? But I think it's extremely important to you to realize that these values go in order. There aren't that many of them, are there? Really, they're fairly simple values based off the numbers 1, 2, 3, and 4. So that cosine is negative 1/2. All right? I'll ask you another one. So that one was negative 1/2. How about the cosecant? Or maybe we should just start with a sine and then we'll figure that. Okay, we'll start with easy instead of throwing you into the deep end. Okay? The sine of I wouldn't give it to you in degree. Why would I do that? Come on, let's get real here. Sine of 7 pi over 6. Sine of 7 pi over 6. Maybe I'll put that one up on the screen too so you can identify the letter first, if that would help you. I don't know if that would help you find it when you're talking to your neighbor. Find 7 pi over 6. Which letter represents 7 pi over 6? J, right? Now, is sine an x value, a y value, or a slope? It's a y value. So what's the y value? Negative 1/2. Look, if you know where 7 pi over 6 is, and you know it's a y value, your answer's right there. Right? Y value, negative 1/2. It sure ain't negative radical 2 over 2. It's not negative radical 3 over 2. It's definitely not negative 1. Identifying where you're at and whether it's an x value or a y value, it's important. Now, I have in this packet practice questions. Yeah, I've got this blank circle in here, right? It's got a whole bunch of blanks on it to fill in. But what I cannot have you doing, as I cannot having you fill this whole thing out, I think the answers are on the next page. So if you get stuck, you can to look at. Okay? But what I can't have you do is this. I'm going to memorize the unit circle. That's what I get kids that do. And guess what? The next chapter comes along and we talk about the... I'm going to have to re-memorize the unit circle, Mr. Staley. You should have learned the last time. We didn't have to memorize a whole bunch of stuff. There's a few things we have to know. And then we get to the next chapter. I have to re-memorize the unit circle. Get to the final exam. I have to re-memorize the unit circle. Okay? I don't need you trying to fill this whole thing out. I need you to think cosine is x, sine is y, tangent is slope. Do we need to talk about the tangents? Sure we do. Okay? But those are your x's and y's. That's it. Those values, 0, 1/2, radical 2 over 2, radical 3 over 2, 1, or their negative counterparts. Those are all the x's and y's. Now, can you take those x's and y's and flip them over if I ask for secant or cosecant? Sure, you probably can. But we do need to talk about the tangents. Sorry, I just wanted to show you. I know you did. I was like, so that one was negative 1/2 also. Okay, what coordinate is sitting right here at the edge of the circle? What coordinate is sitting right there at pi over 6 radians? Radical 3 over 2, 1/2. That's the cosine and the sine right there for pi over 6. Now we know that tangent is the y value divided by the x value. And before we do that, maybe I should have probably started with this one. That point right there. That point right there is what? What's the x value? Radical 2 over 2. What's the y value? Same thing, radical 2 of 2. Oh my goodness, it's like an isosceles right triangle. Why, of course it is. It's a 45, 45, 90 right triangle. Or as they say in radian world, pi over 4, pi over 4, pi over 2. I know you didn't say it like that, but you know, that's cool to me. Alright, so what's the slope of the blue line? What's the slope of the blue line coming from the origin? That's a 1, right? That's a fairly obvious thing. Tangent pi over 4 is a 1. Anytime you have the same x and y value and you divide them, you're going to get a slope of 1. Do you think the green line is steeper than 1 or more shallow than 1? It's got to be more shallow. It's got to be a value smaller than 1. Okay. I think back in middle school we taught you that division is the same as multiplying by the reciprocal. So, what is one way that we could say this? We could say, wait a second, those twos cancel. What does that give me? 1 over radical 3? We can see that it's smaller than 1 because you divided it by something. Nobody's going to say it like that, folks. You will never see, well, you will rarely see people writing it like that. They will, however, write radical 3 over 3. So that's one of the popular ones on the unit circle. We got another popular slope on the unit circle. Probably better figure out the red one. What's that coordinate? 1/2. Yep, the x value is 1/2. That's true. And radical 3 over 2. And let's see here. Let's do a little tangent of pi over 3. So y value divided by x value. Hey, do you think this is going to be more than 1 or less than 1? It's going to be more than 1, isn't it? Okay, so using our division is the same as multiplying by the reciprocal. What do we end up with? The square root of 3. Those are your 3 popular slopes on the circle. Now, there are 2 more that I want to, as soon as you get things written down the way you want them, I do want to highlight 2 more slopes that are extremely important to you besides those 3. Everybody got it, or anybody need it anymore? Okay. I need to know the slope of this line. The slope of that line. 0. I need to know the slope of the blue line. Undefined, also known as no slope. Now, is there a difference between 0 and no slope? You ever heard of cross-country skiing? Cross-country skiing, anybody? Know what it is? Right? You do all the work. Right? You got the skis on, you're moving around. Excluding sniper fire, what are the chances of death? 0. Unless you got bad heart condition or something like that going on, But if you're in good health, and there's nobody shooting at you, pretty good chance you're going to survive, right? Okay? You're on the downhill slope. You're on this like quadruple black diamond hill. You go the wrong way. You go off a cliff. What's happening? You're falling. There is no slope underneath your feet. Chance of death? Pretty good. Right? Unless you came with a parachute. Okay? Alright, which isn't a bad idea, actually, for downhill slope skier. Alright, so, no slope, 0 slope. Don't tell me they're the same thing. Right? 0, none. No slope, no slope. Or undefined, as the term is also called. Those are 2 other slopes that you need to know besides radical 3 over 3, 1, and radical 3.